Hello, Legacy students. Marsh here. So today we're going to talk about describing graphs, so key features of graphs. You're going to want the two foldables I gave you and then your notes so that you can glue your foldables in your notebook. You might also want different colored pens. That might assist you in coloring up one of the foldables that we're going to be looking at today. Some learning targets that we're going to be talking about today, determining local and absolute maximums and minimums on a graph, where a graph is increasing or decreasing and stating those intervals, X-intercepts, Y-intercepts, if a graph is continuous, if a graph is bounded, and also if it's even, odd, or neither. So a lot of different learning targets, a lot of new content that we're going to be learning today on this information. First of all, this foldable, you're going to want to find it. You're going to want to fold on the blue lines that I have on here, and you're going to want to cut the red lines that I have on here. So fold on the blue, cut on the red. I'll give you a minute or two here to do that. All right. Hopefully you pause the video. So in the inside of my foldable, we're going to talk about some of the information. First of all, we're going to talk about X-intercepts. An X-intercept you have met before. That is the point where the graph crosses the X-axis, aka the horizontal axis, right? So on my graph that I have in the middle there, I have X-intercepts at -3, 0, 1, 0, and 5, 0. Now notice how those are ordered pairs. Your X-intercept should always be an ordered pair. Okay? Never X equals -3 because that's not an X-intercept. An X-intercept is an ordered pair. Now, the Y-intercept is the one point where the graph crosses the Y-axis. In my case, on my graph, it is at 0, 2. Again, this is an ordered pair. It has to be an ordered pair because it's a point in space. This is why I was talking about those colored pens, because you kind of mark things in with color here. The other thing we're going to talk about is increasing intervals. Now, this graph is increasing, or a function is increasing on an interval if the y value increases as the x value increases. So that means the graph basically looks like it's going up, left to right. In my graph right here, I have an increasing interval on the yellow line that I just drew in. I also have another increasing interval on that point. Now, this is going to be an interval, and I would write my increasing interval. Now, we are using the x values because I want to know where on the domain am I increasing, because I'm talking about the y's already when I'm talking about increasing, right? Well, it goes forever from the left, right? Because it's going to start all the way going up. It's going to be going up since -infinity. So I would say I started at -infinity while I'm increasing, but I stopped increasing, notice, at, I'll draw a line here, at -1, right? So I would be saying my increasing interval is from -infinity to -1, parenthesis, because technically I'm not increasing at -1, right? But I have one more interval. So what I do is I put what's known as a union, a U. You guys talked about it in rich geometry. It's basically the mathematical version of an and sign, kind of. This with union of that. Now, I start my increasing interval, my other one. Notice how I'm drawing a line. Notice that line is vertical. That's why it's at the x value. So I start increasing on the domain 3, and I increase to positive infinity, correct? So I'm going to increase to positive infinity. Now, the other point, we might decrease on a function. That is when the y values are decreasing as the x value is increasing. So from left to right, the graph looks like it's falling. And in this case, I do have a decreasing interval there. The decreasing interval notice is starts at -1 and it ends at 3. Okay, so it's from left to right. It's the X values. What X values are you decreasing on? The other information that we might find is what's known as a maximum. The maximum is the Y value of the highest point in a particular region of a graph. Basically, these are what I will term as the hills of a graph. Okay, now the maximum of my graph that we're looking at is located at the ordered pair -1, 4. Now, you could either give me, depending on what they ask for, and you kind of have to be on your toes when they talk about maximums. Maybe they'll say, what's the Y value? So that would be 4, right? Maybe they'll ask for the ordered pair. Sometimes they'll even ask for where in the X values is the maximum. So I would say -1. But just keep in mind that the maximum is the Y value. That's the top of the graph. The minimum is the Y value of the lowest point on the graph. In this case, my minimum is at 3, -4. Y being -4, the X value, the domain value is at 3. And then some other vocab that you might hear. You might hear the word zeros, you might hear the word roots, you might hear the word solutions, and you may even hear the word intercepts. All 4 of those are just names that I describe X values of a graph whose corresponding Y value is 0, aka X-Intercepts. Okay? These are all words for X-Intercepts. They do look a little bit different though, because zeros, roots, and solutions always have a value of X equals a number. So zeros, roots, solutions, you're going to say X equals a number. So like X equals a -3 would be a 0 or a root or a solution of this graph. Some other information that we're going to want to talk about, which is continuity. Basically, continuity is a function who is continuous when its graph is in a single unbroken curve. In untechnical terms, I could draw it without lifting my pen from my paper. So like this graph right here, if I start over here on the left-hand side, I would be able to draw the entire graph without picking up my pen. You're going to see a graph that is not continuous in this video. And it is definitely like 100% you're going to see it and be like, oh, that's what they mean by not continuous. All right. So most graphs that you will experience in this class is a continuous graph. We do not look at a lot of discontinuous graphs. Another word we're going to be talking about today is boundedness. Boundedness is a function is bounded if the graph does not exceed a certain limit. So there are multiple ways to be bounded. We can be bounded below, which means that the graph lies above some horizontal line. So that means I can draw a line that's horizontal and the entire piece, everything of the graph is above that line. I could be bounded above, which means that the graph lies below a horizontal line. So that means I draw a line and the entire graph's below it. I can also be bounded, just bounded, which means I can be above and below. So that means I draw 2 lines. You also can be known as not bounded, which means I can't draw a line above and I can't draw a line below. The graph extends up and down forever or to infinity. Let's take a look at what it means to be bounded. You might want to pause so you can write this information down. Let's take a look at it visually. So I'm bounded below. Notice how this graph, it stops kind of here. So I can draw a line below my graph and the graph's never going to go below it, right? This one I'm bounded above because I can draw a line here, but I can't draw a line below because this thing technically goes on to infinity down there, right? Or negative infinity. This guy is not bounded because he goes forever down, forever up. And then this particular graph, he is bouncing back and forth between 1 and -1. So he is what's known as bounded because he is stuck between an upper and a lower bound. They're very strange to look at, And it's going to take us a little bit to understand boundedness. But once you get it, it's a piece of cake. Some other information about graphs. Extrema. Well, just because we talked about max and min, but we really didn't talk about the local and absolute. So local or relative, depending on where you talk, is a high point on a certain interval of the graph. A graph can have more than one local maximum. So it's kind of like a hill or a mountain, but it's not necessarily the tallest mountain. You're kind of pointing out every single mountain and hill. An absolute maximum is the highest point on the whole graph. If it goes to positive infinity, we're going to say there's no absolute maximum. The absolute maximum is basically like the highest mountain in the range, if you want to consider it that way. A local relative minimum is a low point, so that's a valley of our graph. That is going to be we're going to point out every single valley, and then an absolute minimum is the absolutely lowest point on the graph. So that's the lowest valley. If the graph is going to go to negative infinity, we're going to say there's no absolute minimum on the graph. Just a reminder of even, odd, and neither. Remember, to be even, that means you are symmetric about the y-axis. So that means he folds on the y-axis, right? Odd means you're symmetric about the origin. So remember, we folded on the y and then we folded on the x. That's how we were odd. And then if you were neither, you just didn't have y-axis or origin symmetry. So let's actually do an example here. So first of all, I'm going to identify my x-intercepts. So that's where I cross the x-axis. So it looks like I have an x-intercept at negative 4, 0, negative 3, 0. Ooh, that's got to be 0.5 maybe. Kind of guessing. 0.50 and 3, 0. Y-intercept, where am I crossing the y-axis, is at 0, negative 2. Is this graph even, odd, or neither? Well, it definitely doesn't have y-axis symmetry, right? Definitely, if I match fold and fold, it's not going to fold on the y and the x, right? So it's definitely not odd. So this is definitely a neither graph or a neither. If I drew picked up from this left and I drew the entire graph, I'd be able to draw it, right? I wouldn't have to pick up my pen. So is this continuous? Yes, definitely a continuous graph. How is it bounded? Remember, how can I draw a line? Well, I can't draw a line below because I'm going to cut through it, right? There's arrowheads. But I can definitely draw a line above and it's not going to cross past it, right? So I would say it's bounded above. This graph is bounded above. Increasing intervals. Well, from left to right, so if I draw a little car up here, it looks like my car would be going up the hill, right? And it would stop going up the hill about roughly there. But it started at, for the x values, negative infinity, right? Because this this is going to keep going down all the way in the negative direction. So I am increasing from negative infinity to, that looks about negative 3.5, right? Something like that. And then I start increasing again. Looks to be something about right here, right? So that is negative 1.5 maybe. So I'm going to put a union because there's more than one. Negative 1.5. And I stop increasing again at, it's got to be 2. And I think we're good for increasing, but decreasing now, well, I'm decreasing from negative 3.5 to negative 1.5. And then I'm decreasing again from 2, the x value being 2. And notice I'm decreasing forever, right? But we're talking forever in the x values. So that would be positive infinity. Just because I'm going down forever, that's because we are decreasing forever, right? But remember, we're talking x values in increasing and decreasing intervals. Let's talk max and mins. Well, I'm going to do some cleaning here on my graph. I do have a couple of hills, right? One hill right here and one hill right here. This guy, he looks like its maximum would be at -3.5, 1. So I'm going to put it as an ordered pair here. So -3.5, 1. And notice that is not the tallest maximum, right? So this guy would be a local maximum. I have another maximum at 2.5, and that looks like that would be my absolute maximum because it's the tallest mountain in the range, right? And then I also have a minimum down here, which is at -1.5, -5.5, roughly. Now, notice this is not the absolute minimum because it goes forever down, right? Technically, it goes forever down. So this guy would be a local minimum or a local min. Domain. Yes, we're continuing that. We are going to open forever to the left and forever to the right. So I'm going to say my domain is -infinity to +infinity. My range, remember, bottom to top. I start all the way down, so that's -infinity. And then how high does my graph get to? Well, it goes to my absolute max is y, right? So at 5. So my range stops at 5. Notice a bracket on there. Let's try one more example. What you might want to do, guys, is pause the video here. Try this example on your own, and then watch me go through it. So pause the video. Perfect. So let's try it. Intercepts, X-intercepts. Well, I have one at 0, 0, right? And then I also have one at 3, 0. My Y-intercept is also 0, 0. It's right there. Definitely a neither graph, right? This definitely doesn't have any symmetry. This is definitely a continuous graph. Now, here's what's kind of cool about this. There is a open dot in the middle of the graph. That's strange. And then there's this big jump. So this is not continuous. This is a discontinuous graph, technically is the term. Bounded. Well, it's definitely not bounded below, right? Because I can't draw a line. It's just the arrowheads are just going to bust through. But I could definitely draw a line up top and there would be all the graph below, right? So I would say this is bounded above. Increasing interval. Well, I started at -infinity on the x values and I stopped increasing at -2, right? So -infinity to -2, I was increasing. Then we're constant for a little bit, but I did start increasing again from -1 to, what am I going to do with that jump? Well, technically I do have 1, right? But I still increase. So technically, I would say I'm increasing from -1 to 2, right? Because technically, I still am increasing on 1 and 2. So I would say I am increasing from -1 to 2. My decreasing interval, well, I start decreasing at 2, and I decrease forever in the positive x direction. So I would say I am decreasing to +infinity. Now, again, local maxes and mins, absolutes, whichever one. Well, we only have one right here, right? Because this would be a maximum, and that is at 2, 3, it looks like. And this would be an absolute maximum. No minimums because I don't have any valleys. Right here is not a minimum because it doesn't technically go down and up. It actually has to make like either a point or a U on my graph. So there is no minimum there. That's got to be the only one. Domain, well, this is going to be a little weird because technically we don't have -2, right? There's an open dot there. So I'm going to have to make note that this graph's from -infinity to -2, not including him, right? But I still have from -2, well, 1, I do have a closed dot, right? So technically I still have 1. It's kind of weird, but the closed dot fills in that open dot forever, right? So I go forever in there. There's just this random little hole there that we got to notate on our domain. My range, we do start at -infinity. Remember, bottom to top. Do I have to worry about that hole again at -1 for the y's? But technically I have a bunch of that, right? -1 is on the graph again, so I don't have to worry about that. And then I do have between 1 and 2, I do have the graph, right? So I don't really have to worry about that. It does end though at 3 for a bracket. And that is the end of this video. I know this was a lot of information and it is going to be a little bit of a learning curve. And we will get through this information and this is going to continue throughout the year. So we will get a lot of practice with this information. So don't worry if you're kind of confused right now. We will definitely do a lot of practice. But until then, I will see you later, Savers.